Hello, everybody. This is the second lesson in Unit 4, Bonding. Our aim today is how can we use Lewis dot structures to save time while drawing the valence electrons of an atom or an ion. There is a bookwork associated with this lesson. It'll be on a handout, and I will copy it for you, and you'll see it at the end of this lesson, so I'll show it to you. That's basically it, but I do need you to go ahead and copy down this do now. And we will answer these questions in class tomorrow, but do please copy down the do now on a separate piece of paper before class. Okay, so our mini lesson. Let's review for a moment why atoms form ions. Let's find an element for each of the three columns below, and we'll identify the groups in which we found the elements for the above task, and we'll predict the charge that each atom will obtain. So I need to choose an atom that has one valence electron, and if I'm scouring my periodic table, I can find several. But this one I'm going to choose is sodium, and it's in group 1. And that's the reason why I chose it, actually, because all the elements in group 1 have one valence electron. And that means that its charge is most likely going to be +1 as it loses that electron. If I want an element that has 2 valence electrons, I could choose an element such as magnesium. It's in group number 2. That's how I knew that it had 2 valence electrons. And its most common ion charge will be +2 after it releases 2 electrons. And an element that has 7 valence electrons could be an element such as fluorine. It's in group 17, which means that it has 7 valence electrons. And its most common ion charge would be -1. And the reason for that is that since it has 7 electrons in its valence shell, if it gains one more, that's how you get a -1 charge. If it gains one more, it'll have 8, which would be a stable configuration. But we have these things called Lewis dot structures. And Lewis dot structures are our way of representing those valence electrons we were just talking about, but doing it in a way that's visually organized and instantly recognizable. And there's even a little bit of purpose behind it. What I will say about these dot structures is that they represent the valence electrons only. None of the other electrons count. And there are some rules for them. You may not put more than 8 dots around any element symbol. And the reason for that is that there are no more than 8 electrons in a valence shell. Only 2 dots may be drawn per side. So if you say that the element has 4 sides, and 8 dots maximum, 2 per side, 4 sides, then you're really imagining something like this, where you have an element in the middle. I just chose an X to represent any element, and you have 4 sides, so 1, 2, 3, and 4, and you have 2 electrons per side. So I have numbers in here just to represent the locations of electrons and the order in which I place them, but ultimately you will just put a dot instead of a number. But you'll put them in the order that these numbers represent. So I will erase what I've just started just so I can go over that part one more time. These electrons are going to be placed in a certain order. As you can see from the diagram, the first 2 electrons go together. So if you have an element that has 2 electrons, you would put them in just like that, first and second. And if you had an element that had 3 electrons, you would put in the first 2, and then you would add a third right there. If you had an element with 4 electrons, then you would put in the first 3 and add a fourth there. If you had an element that had 5 electrons, put in the first 4 and add a fifth. If you have an element that has 6 electrons, this is where it's going to start getting a little crazier. Put a 6th electron there after you put in the first 5. 7 electrons, that's where your 7th one would go, and here's where your 8th electron would go. And now I'm full, so I can't put any more electrons in. But just as a review, the order was first electron goes here, second electron here, third, fourth, fifth, sixth, seventh, eighth. So in essence, I put my first 2 electrons together, and then I alternated sides, here, here, and here, and then I switched back to the beginning and alternated sides again. Alright, so let's do an example for fluorine. Fluorine is in group 17, and therefore it has 7 valence electrons. I'm going to put the first 2 together, and I need to include 7 electrons, so I need to include 5 more. Remember, from here I'm going to put 1 electron per side and alternate sides until I come back to the beginning. So if I put in my first 2, here's my third, fourth, fifth, sixth, and 7th electron, fluorine. Another example could be lithium. It's in group 1, and therefore it has only 1 valence electron. This is going to be really, really hard, so get ready for it. Done. Okay, so I have a little bit of a sense of humor there, but that was not a hard one. What I would point out is that Lewis dot structures, and this is kind of their purpose, guys, is that when you draw elements like this, you can really see the relationship between lithium and fluorine. The electron right here that lithium has is definitely going to come right over here and nest in that spot on the fluorine atom if the lithium and the fluorine are allowed to interact. Because if that happens, then the lithium will have an empty valence shell, which reveals a full valence shell underneath, and then fluorine will have a brand new, shiny, full valence shell. In which case they would both have an increase in stability, energy would decrease as a result, and you would have a stable bond between the 2 elements. So once we have those 2 ions, the lithium ion and the fluoride ion that result from the bond, we need to be able to draw them with dot structures as well. They have something in common. The fluorine ion, since it has 8 electrons in its valence shell and is stable and therefore won't undergo any more changes, then we're going to draw it with its 8 electrons, and we'll put brackets outside it to show that it's no longer changing, and we'll include its charge. So this is what I mean by that. Here is the symbol for fluorine, and after it receives that 1 electron, it's going to go from 7 electrons, there's my 7 electrons, to 8 electrons. So it has 2 electrons per side on 4 sides, and then put brackets around it like this, and that's going to show that it's no longer changing, that it's stable, and include its -1 charge. And once you have that, you have a perfect Lewis dot structure for the fluorine ion, which we can call fluoride. Now for the lithium ion, it's similar, but there is one important difference. We put the lithium symbol in the middle, but the lithium atom lost an electron, and when it did that, it revealed a full valence shell underneath. However, I'm not going to draw that full valence shell. I'm actually going to leave the area around the lithium atom blank. And when I do that, what I'm indicating is that when it achieved stability, it did so by losing electrons. And the other way I can show that is by putting in its positive charge, meaning that it lost electrons. But the brackets around it mean that it's stable and that it does have a full valence shell. But by showing it empty inside the brackets, I'm also showing that it lost electrons. So at this point, we've reached the end of the mini lesson. What I'm going to do right now is just preview for you the worksheet that you're going to do in class tomorrow. So essentially, I'll have this printed out, and it just has a variety of atoms and ions on the front page. And what you're expected to do is to give me a Lewis dot structure for each. So hydrogen is an atom, but I also have some ions in here. It looks like the first one is a sodium ion, an Na+1, but I have more ions under that. So we go from atoms to ions, and then I have more ions up here at the top. Ions, and then I have some noble gases. I have a noble gas. And some more ions and some more elements, and then it just gets all mixed up. So what you're going to do is you're going to make a dot structure for each one of those. And you'll also answer these summary questions. So go ahead and do copy down these summary questions, but not the pair up, because that would take you forever. And that concludes the lesson for today. So just make sure you have all your notes ready and you have your summary copied and the do now copied, and I'll see you in class tomorrow. Thank you.